You're watching Power Nation.
Hey, it's time again for horsepower, and this time with a new project car of ours that's a perfect prospect for some power and performance upgrades. Why is that? Well, think about it. The Chevy Monte Carlo was the last rear-driven, full-frame, carbureted V8 that Chevy made. Oh, here's some other good reasons. They're plentiful these days and pretty affordable for as little as $3 grand. The body was Winston Cup based with a shovel nose front end, quad headlights, blacked out grille, and monochromatic paint job. It was called a hot rod for the 80s with an L69 HO305 making 180 horsepower.
Today we're going to use our 86 model to show you how we think Chevy should have built the Monte Carlo. For starters, the weak 180 horsepower 305 might have been all right back in the mid-80s, but just imagine over a 500 horsepower big block shoved between those fender wells.
Yeah, like this one. It's a GM Performance Parts ZZ502 Deluxe, a crate motor that comes with everything you see here. Now the compression is 9.6 to 1, horsepower 502 of course, and it makes 567 foot-pounds of torque. Enough power to turn our simple SS into a mighty Carlo.
Monte Carlos only came with automatics, so banging gears wasn't an option, but we're going to fix that with a Richmond Super Street 5-speed like this one. Now it's a direct replacement for Chevy, Ford, and Mopars, and it's designed for higher horsepower street cars with up to 600 foot-pounds of torque. Now it's got wider cut gears, a long billet shifter, and a .77 overdrive in 5th gear.
We know some of you have probably been thinking about an automatic to manual swap of your own, and well, during the course of this project, we'll show you how it's done using a kit we've got ordered. Meanwhile, it's time for us to tear into this tired old mouse and give it a lift, literally.
We should be able to pull this old motor out without removing the hood. Move it up a little, forward a little, and so on. Now you always want to use a hoist that's rated at well over the weight you're lifting. Our Matco floor crane is rated at 4,000 pounds.
There she is.
All right, come on down with her. Well, that was easy enough, and just like I thought, we didn't even have to remove the hood. Now we're still waiting on some pieces and parts for our trainee conversion kit, so we're going to go ahead and move to another piece of the project that involves making this Monte Carlo handle and drive a lot more like a sports car.
This too is an upgrade that applies to just about any muscle car. We're going to replace the stock suspension with this inclusive TVS kit from Hotchkis. You know, like with engines, mixing and matching suspension components can be risky. These, however, have been designed and tested to work together as a system, like the front and rear coils, front and rear sway bars, trailing arm mount braces that are adjustable, and this complete adjustable rear end suspension system. Now, we also stepped up and got some of their Bilstein shocks that have been specially tuned to work with the rest of the setup. We'll get started by supporting the rear end with our jack and removing the rear shocks. Then the rear springs can come out. Next, we unbolt the upper control arms, then the lower control arms.
Needless to say, you don't have to remove the whole rear end to do the suspension upgrade, but since we're stepping up to a big block 502 and a Richmond 5-speed, I don't think this little 10-bolt will withstand the power. So we're stepping up to one that'll definitely handle the abuse. It's a 9-inch rear end assembly that's brand new from Master Power. Now they stuffed the front of it with a Detroit locker and 411 gears. 31 spline axles work their way out to a cross-drilled and slotted 11-inch rotor, and that's capped off with a set of their aluminum 4-piston calipers. And check this out, a separate caliper for the emergency brake system. Before anything else though, to prevent a rusty rear end, I'm going to apply some paint to the rear end's bare metal.
Well, after a quick lunch, the paint's dry, and well, we're ready to bolt these upper control arms to it. Now, it's easy to see how the new ones are a lot stronger than the stockers to improve handling and traction. Also, you can adjust the pinion angle to correct any driveline vibrations. Now, to prevent any suspension squeaks, we want to apply some of this Teflon grease from the kit to the bushing faces. A little bit goes a long way. Now, we can go ahead and bolt up this upper. And same thing goes for the lower control arm.
Hey, we're back to finish up today's work on our latest project vehicle. It's an 86 Monte Carlo that's going to be a lot of fun to drive when we get it finished. Now that's thanks to a 502 crate engine and an automatic to manual transmission conversion. But first, we've got to get this rear end, suspension, and brake upgrade mounted in the back end. We just installed new Hotchkis upper and lower control arms on our 9-inch rear end from Master Power. Now we can bolt them to the frame. The new front bolts are longer than the stock ones for a good reason.
They allow us to install these adjustable trailing arm mount braces. Now what these do is triangulate the control arms with frame mounts, giving it extra strength for all that extra horsepower. Now we're just going to tighten down the nuts finger tight. Well, now we can drop in the new springs, jack the rear end up a couple of inches, and install the shocks. Now we can tighten the control arm nuts all the way around. Finally, install the new rear sway bar to complete the suspension upgrade, along with our new crate rear end.
Next, time to get dirty again. Up front, removing the shocks and sway bar. Then, after separating the spindle from the upper control arm, we can pull out the springs.
Master Power is probably best known for older muscle car brake kits, but nowadays they got one for our Mighty Monte. Now this front assembly comes with a 12-inch rotor that's cross-drilled and slotted to dissipate gases. Oh, and it's a full 1 3/4 larger than our stock one was. Now the calipers are an aluminum 4-piston design, and back here a direct replacement spindle. Of course, the kit comes with hoses and hardware. Now, anytime you convert rear drum brakes to disc brakes, you're going to have to step up to one of these dual diaphragm power boosters and a master cylinder with a larger bore diameter. Why? Well, quite simply, the disc brakes require more pressure than the old drums do.
Before I install the new Hotchkis spring, check out the diameter difference. The stock spring is a lot smaller in diameter, and it's also a lot taller. Now the new Hotchkis spring will end up giving us about a 1-inch drop. With the spring in place, we need to jack up the lower control arm. That way we can bolt up our new brake assembly at the spindle.
Our Hotchkis kit also comes with a front sway bar that's lighter than stock, but a good bit thicker. Also, it has these polyurethane bushings that are also greasable, or is that greasable? Well, you get the idea. When you bolt these brackets up to the frame, make sure this split in the bushing here is facing forward. Then finish the job by connecting the sway bar to the lower control arm with a set of end links.
One more upgrade for the front. Tie rod ends wear over time, and this will give you steering and tracking problems. So we went to our local O'Reilly store and picked up some new ends just for the added insurance. And we're going to install them using a new tie rod sleeve we got from Hotchkis in the kit. With the old one out of the way and using new hardware, we bolt this end to the drag link and the other end to the new spindle. Anytime you replace a bunch of suspension parts, especially on the front end, including tie rod sleeves, make sure you get your car realigned. If not, you're going to have premature tire wear. One more thing, you guys know the drill. Make sure your brakes are bed in properly before you put them through any hot heat cycles.
Good advice. And good start today on our new street machine project. Next time we get it in here, of course, we'll drop in this 502 big block and show you how to swap out a boring factory automatic trans for a gear-banging 5-speed manual. What else would you expect from a Mighty Carlo? Well, coming up, we'll see how much bang for the buck we can get out of a hydraulic cam conversion. Everybody knows that hydraulic roller cams are the way to go if you want to get more power and torque from your street machine. You might say that the logic is right here in the lobes. A flat tappet cam's lobes are steeper than the hydraulic rollers, and that means the valve's going to be held open at a higher lift for longer. Of course, converting to a hydraulic roller involves more than just a cam swap. So, is the conversion worth the money you'll have to shell out?
Well, that's what this bang for the buck's all about. We're going to use the stock Ford 302 we picked up at O'Reilly's, make the conversion, and then use our DTS dyno to measure its power gains.
The conversion kit we're using comes from Crane and includes, of course, the camshaft and things we'll need like new springs and retainers, roller rocker arms, hydraulic lifters, and this new timing set. Well, more about this later. Right now, though, it's teardown time in the dyno cell.
To begin the conversion, we need to remove the valve covers, the intake manifold, the factory valve train, the balancer, water pump with the timing cover attached, the timing chain, and finally the camshaft.
Hey, see the difference in height in these stock lifters and the hydraulic rollers? Well, that extra height could cause these stock springs to collapse and bottom out. That's why we installed new springs that are made to match the rest of the components in the kit and compensate for taller lifters.
The cam goes in next. By the way, the intake duration is 208 and the exhaust is 216 with 530 lift on both the intake and exhaust. Make sure you check your cam card for the proper firing order since it did change. The new cam gear and billet timing set go on next. Always remember to replace the timing cover gasket anytime you have the timing cover on or off.
Good advice. Well, now we can go on and install these lifters that come with anti-rotation guide bars that go on the cylinder side of the block. Now, because of the extra height of these lifters, we had to remove the heads to install them.
Now we can bolt the heads back up, of course, using new gaskets. Then, after installing the rocker arm stud conversion pieces, we can drop in these new shorter push rods, followed by the roller rockers. To reduce wear, they've got a wide contact roller tip and a heat-treated pushrod cup.
There's one more modification we got to make before we complete this conversion, and that's installing this bronze distributor gear. Otherwise, our billet cam would eventually destroy the stock one that's only made of coated steel. It installs easily by using this stock pin to keep it in place. With that handled, we can button up the rest of this small block, change the oil, and fire it up.
After giving the motor a good warm-up, we're ready to make some pulls, and we're going to do it on 87 octane fuel. Now, it'll typically take you about 4 hours to convert your engine to a hydraulic roller, and we're about to find out whether or not it's worth the time and the money. The baseline for this 302 was 210 horsepower, 302 foot-pounds of torque. Now our small block Ford is making 248 horsepower, 325 foot-pounds of torque. To recap this bang for the buck, we used a Crane hydraulic roller cam conversion kit. We made 38 horsepower over our baseline and 23 more foot-pounds of torque. The price for that added power, $949.95. Now that the car can handle the extra power, we're ready to drop in our GM Performance Parts ZZ502 Deluxe crate engine. Before we do though, we need to beef up the factory mounts using these urethane inserts from Prothane. They'll absorb the vibration of our big block and they install inside the factory clamshells. Oh, there's something else we need to do before we drop in that new motor. We're stepping up to a dual diaphragm booster and larger bore master cylinder to compensate for that added line pressure needed thanks to the disc brake upgrade. So while we've got the room, we might as well remove the factory parts by disconnecting the brake lines and removing 4 bolts inside the car. Then we can install the new booster and master cylinder in their place.
Well, these headers ought to make that 502 exhale properly. They're super comps from Hooker, and they're designed for big block engine swaps and G-bodies like ours. Now, they've got 2-inch primaries that feed into 3.5-inch collectors, and they got a ceramic coating. Now, these pieces come off for an easy installation around other components. I'm going to lay these in place for now. We'll bolt them up when we get the engine in.
Well, it wasn't very pretty, but after a few modifications to the headers and a little bit of cussing, we finally got it in. The good news, we didn't have to remove the factory AC. Who wants to drive around in a hot rod that's hot on the inside anyways? Now we can bolt up our headers with gaskets and hardware from the kit.
With a high horsepower engine, you need a bell housing that's stouter than OE cast aluminum. This one's from Lakewood and it's hydrofoam from steel plating, and that's for thickness and strength. Anytime you install a new bell housing, you got to make sure it's in proper alignment so that the throwout bearing and clutch fork operate smoothly, and that you've ensured that the input shaft of the transmission and center line of the crankshaft are centered up. Well, here's a tool that'll help you do that. It's a bell housing indexing fixture from a company called Precision Measuring Supply. With the dial indicator mounted to the crank flange and the stem mounted inside the transmission hole, rotate the crankshaft 360 degrees and note the highest readings. Then reset the dial indicator and rotate another 360. Combine the highest readings, in our case 4 thousandths and 5 thousandths, divide by 2, and anything under 5 thousandths is acceptable. Now, if the numbers prove you do need to move the bell housing, you can use some of these offset dowel pins from Lakewood to get it lined up. With the bell housing off again, we can get going with this safety plate on the dowel pins, followed by a balance plate that goes on the crankshaft.
Our aluminum flywheel, it came from Fidanza. Now the friction surface, it's made to handle any kind of clutch material from organic to ceramic. Now the ring is also made of a 1045 steel, which is super strong, and it's removable to save you time and money down the road. Now we can bolt up the flywheel using ARP fasteners. We also went with Fidanza for our clutch setup, which comes with a Kevlar clutch disc. Now they also include a pressure plate, which the manufacturer claims will last 5 times longer than a stock piece. Now the kit also includes an alignment tool for easy, accurate installation.
Now we can install our bell housing permanently this time, and along with it we need to install this clutch fork and our throwout bearing, otherwise we'd never fit them through these holes here. Notice also we've installed this pivot ball, and well, as the name implies, it gives the fork a nice pivot point for smooth operation. Now on the other side is a pivot bushing. We'll make final adjustments to it once we get our linkage hooked up. Well, this 5-speed Richmond Super Street Trans goes up next. Now this is a NASCAR type design that's rated at 600 foot-pounds, and as our cutaway reveals, it's got very robust gears, much more so than street models. Now Richmond also offers this longer shifter setup, and you see this in a lot of circle track cars for good reason. That's because of the short solid throws and reputation for durability.
We got the transmission in place, and now it's bolted to the bell housing, as you can see. What you didn't see was what we went through to make it fit. We had Tech Center Tommy cut out part of the trans tunnel to clear the long shifter since it's mounted so high on the transmission. It also had to be big enough to clear the linkage. After the surgery, he then used some 18-gauge sheet metal to make a patch panel. The next step was finding a cross member that could support everything and allow us to run our dual exhaust. So we got a hold of the guys at Honest Charlie's, who have this bolt-in cross member that's specially made for the G-bodies and the Richmond transmission. Now they also have these available for any other transmission combination. It's got a lot of strength, and with a double hump design, it should easily accommodate a big dual exhaust system. Speaking of exhaust, our big block 502 is going to be moving a lot of air, and it needs to sound pretty good too. So we're going to use a Flowmaster Super 40 with a 3-inch inlet and a 3-inch outlet. We're pretty tight for room under the car too, so we're going to have a pretty unique system utilizing a 3-inch universal tailpipe kit and a metal catalytic converter. After some fitting, cutting, and welding, we've got our Y-pipe made. Now some of you may be wondering why we're using the cat. Well, it's a local law here in Tennessee, so be sure to check your local and state laws to see what you have to run on your exhaust system. This will have a turn down on it, but since the muffler's in place, we're through with the system. While we've still got the car in the air, we might as well install the GM starter that came with our crate engine. Now it's a lightweight gear reduction piece that fits both small and big block Chevys. And it bolts up to the engine block.
We're back on the ground where I'm going to get a jump start on that 502's accessory drive system. Now this is a GM Performance Parts kit, and we had it rushed to us from Latoff Chevrolet in Arlington Heights, Illinois. It's a deluxe kit for cars with AC like ours, and I'll get started with our crankshaft drive pulley. It installs in front of the balancer with 3 bolts from the kit. Now we have to remove the short style water pump that came with our crate motor and replace it with this longer style pump from the kit, and that's to keep the pulleys lined up. Next, the water pump pulley can go on, and with a stud in the right hand cylinder head, we install the main AC bracket, followed by the AC compressor and the brace. We pre-assembled our alternator and power steering pump to go on now. The tensioner needs to go on next, followed by the power steering pump pulley, and now the idler pulley, and finally the serpentine belt from the kit to complete the installation.
Today we want to finish up the 5-speed conversion using this kit we picked up from Honest Charlie's. Now it includes the pedals, the Z-bar, pivot ball, neutral safety switch, and all the necessary linkage, not to mention the hardware. Now the first thing we're going to do is jump inside the car and hang some pedals. They install using the existing bracket from the original brake pedal. Then we slide the Z-bar onto the pivot ball on the engine block and attach the second pivot ball and bracket to the driver's side frame rail. Next, we connect this rod from the pedal to the Z-bar. And finally, we can connect the push rod from the clutch fork to the Z-bar.
Well, needless to say, that 502 is going to need a lot more fuel than the stock 305 we took out of the car. So Holly hooked us up with the parts we need to build a new fuel delivery system. And it includes this HP pump that flows 140 gallons an hour at 7 psi. Now this thing's a geo-rotor design for durability, and it can feed motors making up to 900 horsepower. Well, we'll show you how to install it after we remove the fuel tank for some modifications. To make this easier, we remove fuel from the tank before going to work on it.
To pick up fuel from the tank, we're going to use the stock sending unit, but I went ahead and cut off the barb on the pickup tube, and we're going to weld on this sleeve fitting to dash 8 that's new from Earl's. That way we can run dash 8 line straight from here to the fuel pump. With the pickup back inside the tank, we can move on to the fuel pump.
As with any electric pump, you want to mount it as close to the tank as possible and in a position where it can be gravity fed. Well, next, we route more of the new fuel line up to the engine. Now, of course, we don't want too much fuel flowing into that carburetor, so we'll mount up this fuel pressure regulator designed to flow from 4.5 to 9 psi, and we'll mount it down here on this bracket from the kit.
Now we can go ahead and install the carburetor. Now our GM crate engine came with the Street Avenger 870 with a vacuum secondary and electric choke, which is fine for automatics. But with our rear end gear ratio and 5-speed transmission, we're going to run into a little hesitation after the shifts. So we stepped up to this other Holly, which has a mechanical secondary. It's a double pumper and flows 950 CFM. From the regulator, we're running our supply into the gauge fitting and then to this fuel line kit from Earl's with a dual feed to the carb.
The distance between the motor and that electric fuel pump back there can cause a voltage drop in the wiring, so with that in mind, a relay kit's always a good option. This one came from Holly. It's a basic 4-wire setup, and it's a 30 amp capacity working with 12, 16, and 24 volt systems. I'm mounting the relay box next to the fuel regulator here on the frame and routing the long red wire along with the fuel line and back to the fuel pump where it's connected. Now the other red wire connects to this fuse holder, then on to the positive battery terminal. The black wire is a ground, which we've got bolted to the frame. Now this green wire goes to a switched 12-volt source, which in our case will be this electric choke connection, but we'll need to wait and route this harness so we know how much to cut this wire.
We're in the final laps of the race to finish our mighty Carlo, now with a 502 horse big block engine, a 5-speed trans, and more upgrades to make it a trick late model hot rod. When it comes to big buildups like this one thing definitely leads to another. Case in point, this big block 502 needs a lot more fuel than the factory 305. So we just modified the fuel delivery system with a high flow fuel pump, fuel regulator, and relay kit.
Our concern now is keeping that big block cool enough. The stock radiator wasn't designed to work that hard, so we're going to try something from Flexolite called a Flexo Fit. It's a cross-flow design, and hey, check out this feature inside. It has internal fins that absorb heat from the coolant and radiate that heat to the external fins for more efficiency. Hey, here's another cool feature, no pun intended. These T-channels on the side tanks allow you to mount the brackets in a way that you can slide them up or down for perfect positioning.
We're going to mount this Hayden 16-inch electric fan right to the radiator. Now this thing has a high output motor that spins the reversible 8-inch blades and flows 1,300 cubic feet per minute. Now it's housed inside this finger guard shroud, and they make it pretty easy to mount using this integrated mounting kit that's supplied with the fan. Next, we can lower the radiator fan assembly into place. Secure it with rivets. Connect new hoses, and wire it to the harness using a relay kit.
Now we can go ahead and install this throttle linkage kit from Locar that comes with a bracket, linkage adapter, and the other parts needed to make it work smoothly. Hey, how about a little bling for the dashboard next? We've been looking for a reason to try out some of these laser gauges from MSD. There's no needle, just a dual sweep LED readout. Of course, we got one for the tach, water temperature, and oil pressure. And of course, you got to see these things powered up to appreciate them, and you will after we get busy. We're installing them in the dash of the car, which for us involves cutting 3 holes in the factory dash cover with a hole saw, then marking and cutting holes in the dash itself. Well, now we can load the gauges up in the panel. Hey, they actually fit, and that looks great. Now let's see how they're going to look up here. Hey, pretty cool, I would say. But before we install them with the brackets, we need to handle the wiring. For all 3 gauges, we've mounted the grounds to the floorboard, the positive 12-volt sources to the factory stereo harness. Under the hood, 2 wires from the water temp gauge go to this sensor. From the oil pressure gauge, this weather pack connector goes to a sending unit. Finally, the tach gets its signal from right here at the distributor.
There are a couple ways you can program these gauges. Let's take the tach for example. You can set the shift light RPM by simply touching the screen and holding until the sweep reaches the desired RPM. Then just let go. They also come with software and a serial port adapter so you can program them on your PC. This way you can set all your highs and lows and so on.
Next, I'm going to install this drive shaft from CCI Driveline with a Turbo 400 slip yoke and 1350 U-joints out back. Now, you remember that black wheel look that NASCAR had going on in the 80s? Well, check this out. We're bringing it back with this setup. We found these wheels in the POWERBLOCK storage area, powder coated them black. Now they're ready to make a new fashion statement, we hope. We wrapped them in Bridgestone Potenza rubber, 235/40s up front, 255/50s out back.
Well, I guess you either like it or too bad. Now we still have a little bit of work to finish up on the 502 before we fire it up. We're going to see how it performs on the dyno jet and out on the street. Well, are you ready to see how mighty we made the mighty Carlo? Well, today's the day and we're glad you joined us for it. Now we had a lot of fun building this project using various performance parts on this G-body from the mid-80s. We started the project with a 9-inch rear end we got from Master Power brakes. We also upgraded the brakes all the way around and beefed up the suspension with the Hotchkis kit. All that was to make way for our ZZ502 crate engine with long tube hooker headers to help it exhale. But first we had to give it a manual clutch, which we did with a setup from Fidanza, followed by a Lakewood bell housing. After a little massaging for fitment, we installed the Richmond 5-speed transmission and bolted up a crossmember from Honest Charlie's, along with their 5-speed conversion pedal kit. We also handled the exhaust thanks to Flowmaster and installed a GM accessory drive. Last time, we upgraded the fuel system with the Holley high-flow fuel pump, regulator, and relay kit. Plus, to cool down that big block, we attached a Hayden electric fan to a Flex-A-Lite radiator.
Finally, we decked out the dash with these MSD laser gauges. Now, before we can take the car out for a ride and throw it on the dyno jet, well, we got to get the carpet in, the seats in, and modify this console by cutting out this center section, laying in a plate, and, well, you'll see. After securing this steel plate, we can take a measurement, then cut a hole in it for the shifter. All right, to finish it up and dress it up a little bit, we added another plate and this rubber boot we got down the street at our O'Reilly store. Let's see how it works. All right, a couple screws and this thing's in. Now we swore we wouldn't do anything else to the interior, but I couldn't resist adding these cool billet pedal pads from Low Car for just a little dress up.
We ran into a little bit of a clearance issue with the AC compressor in the hood. So what we're gonna do is cut out a little area of this plate. That'll allow the hood to shut all the way, but we're still gonna leave the plate there to protect the hood from a lot of unwanted heat. I'm using a Sharpie to mark around the compressor. Before cutting out a square with the cutoff wheel. Then, with the shield bolted back up, we're good to go.
Hey, good job fixing that hood. Now I get the honor of firing this monster up. All right, that thing sounds vicious.
All right, he got the honors of starting it up. I get the honors of driving it first. Get out. I'm taking this thing out on the streets.
All right, all right.
Our first stop in this car was the closest alignment shop, which is a must anytime you make suspension upgrades. Next, a sequence of stops and cool downs to bed in the new brakes. So far, so good. Now, I don't want to hammer it too much and wind up in a cow pasture, but I just got to get a little taste of that 502's power. Man, I'd have to say this mighty Carlo handles and brakes just like we hoped it would. Now, I know it's making a lot of power at the rear tires, but I'm dying to find out exactly how much. We'll have to head back to the shop to find out. After securing the car on the dyno jet and a quick warm-up, we'll be ready to see how much of that 502's power gets transferred to the rear wheels.
Hey, Mike, check this. 513 foot-pounds of torque and 421 horsepower at the rollers.
Man, that's really respectable, especially considering the average power loss through the driveline using a manual transmission is 15 to 18%.
Yeah, I'm no good at math, but I know that's mighty respectable.